Okay, so hello everyone. So today I'm going to talk about the our IBN or Intent Based Networking demo. So this is joint work with some people from Cambridge, Marco and Maharshi, and Ali and myself from Lancaster University. So these some of you have already seen the demo. So I'm going to add some slides about so put the context if someone hadn't seen it yet, and I added some slides about what's next for the future. So what is intent-based networking? This is like quite simplified definition, kind of. So nowadays, if you want to interact with the network or your system, you basically use this CLI-driven solution, command line interface, where you basically connect to each of your devices and push like a script or a piece of code to tell the network what to do and how to do it. So the idea of the intent-based networking is basically you kind of define or express what do you want so what you call the intent itself, and you let the some sort of artificial intelligence kind of translate and map this intent to something of how to do it, and tell the system using some orchestration how to do it and how to deploy it. So the context here of this demo is, of course, a context of an internet service provider. And I'm going to present three kind of different use cases. The first one is about traffic engineering, where we basically kind of tell the system how to reroute or route the traffic between A and B. The second one is the predictive maintenance, where we see that we have kind of a system that kind of predict the remaining useful life of certain switches. And if anything goes wrong, or predict that remaining life of a device is going low, it will trigger an action. And the third one is the service protection period. We're going to see that later on. So during this presentation today, I'm going to overview our implementation of intent, and specifically I'm going to talk about how we do the extraction, the translation, and the deployment of the intent. In the second point, I'm going to talk about the predictive maintenance and the difference between different agents that we use, and the remaining useful life that we're going to keep an eye on. The agent. In a third point, I'm going to talk about the topology that we use for our demo, and show the realistic topology of BT. Before the demo, I'm going to talk and define our three different scenarios. And finally, after the demo, I'm going to talk about what's next. So here, I'll define or show an overview of intent and or at least our implementation. So basically, we have an end user that talk to the system through an input system, like it might be like the keyboard or the microphone, and ask the system what he wants. So basically, this request goes firstly to the extraction, where we basically extract from this human being intent the keywords that we need, and send them to the translation part, where we basically map these keywords to more like an intent language, and send it back to the user to validate it if it's happy with it or not. And if it's the case, we will map it again or like translate it to something more technical, so to build it and deploy it to the system. And finally, so we have our loop. We send back the feedback to the user through like through sounds, saying that the intent was deployed or not. So I'm going to start with the extraction. So for the extraction, I use the Dialogflow, which is a Google intelligent artificial based on intelligent artificial system that kind of help to extract the keywords from a human being request. So basically, it's a model that you have to train to understand what you're saying actually in your use cases. So, for example, here there is, for example, the action forwarding. So basically, kind of train it to define the action. So what do you want here? The origin, so forwarding. So the action is probably going to be forwarding, and the origin is like from to the destination, and you define the path and what's the target. And for example, you have, so this is kind of the general definition, and that's of the action, the parameters. And after you have to kind of train it with different phrases. And for example, here you can say forward the traffic between host 1 and host 7 through switch 1, 7, and 12. And you can tweak it a bit. Like here, there's an and, there's no and here. Instead of through, passing by, going through, using the route, etc., between, from, to. So this is just some examples, and so you have to, and so the system will start picking up. So forward is the action here in yellow. The origin is H1 or H3, etc., and the path is a set of switches here. And so you give it some example training phrases, and after that, it will be able to kind of pick new words that you didn't define yet. And for example, if we pick here the action in yellow, we can see here that we define some actions or some verbs here. So like add, route, or protect, and you define some synonyms like add or attach or add on, route, reroute, direct or redirect. And it's basically, so you give some examples, and if you kind of, when you request a new word, it might be sometimes able to kind of understand that what do you mean by the action exactly. If we go to the example and I say reroute the traffic between H1 and H7 through S1, S7, S12. So it's basically you get Dialogflow pick up the keywords that you defined, and it's basically you know now that the action is route, the origin is H1, destination H7, and the path is the following one. And the good thing about Dialogflow is that you have multiple connectivity, and you can use it with Google Assistant, what we were going to do, or Slack, or other system like Twitter. Once you have these keywords, you go through the translation part, where you basically try to kind of create now like an intent language. So we're using NILE, which is not kind of perfect or not like deeply defined yet. So we extend it and we use some homemade code. So it's basically if you said, for example, the previous example, you collect the keywords, and kind of now you write this NILE code or intent code language where you say define intent for what intent. So do what the action is routing for the traffic, which is a target, and from H1 to H7, following the path S1, S8, S12. And if I go back to the original NILE, how it was defined is basically there is no action. So it's basically everything is around add, adding middle boxes actually. So there is no flexibility. So what we did here is we defined kind of the action, do the action. And now we can, for example, having like root or forward, add, delete, protect, etc. And once you have this NILE or NILE language, you send it back to the user. The user is happy with it, can read it and understand that will cover what he asked first. So if you say yes, I'm happy with it, so you go to the deployment, and so to do the deployment, we have our homemade code sitting in a Heroku server, and we use this PLY Python Lex YAG to kind of going from this intent language or NILE language to something more technical, and for example translate the host one to its specific MAC address, etc. And just a word like that, we during the development we use some DevOps techniques where basically when you push your code to GitHub, it's automatically get deployed in Docker or deploy using a webhook to the server sitting in Heroku and get so tested and deployed directly. So to summarize our implementation, so when we use the input, so we use Google Assistant or Slack. The extraction is made using Dialogflow. The translation is a piece of code that is sitting in Heroku, send it back to the user through Google Assistant. And if the user is happy, we activate through the webhook the building part in another Heroku server, and we deploy it. And finally, send the feedback through the Google Assistant to the user. So now I'm going to talk quickly about the predictive maintenance. So basically, we have a set of agents. So each agent, the digital asset agent, is sitting next to or like probing a specific switch. And so we can see here that the switch is talking to another switch, for example, through this route, the green routes. And so the digital asset agent is collecting data from each switch and sending it back to the one supervisor agent, which is a centralized agent. And it collects different set of data like the temperature, the CPU, the RAM, and send all this data to the supervisor, who kind of, in this specific demo, it can do any kind of calculation. But in this specific demo, we kind of target the what we call the RUL, which is the remaining useful life, and is basically using some to predict using some pre-trained recurrent neural network, RNN, to see if to predict the remaining useful life of the switch. And if at some point detect that the remaining useful life of, for example, this switch is less than the threshold, it's going to alert through the Slack channel the user. And if the user say, yeah, we need to do maintenance, so it will ask for rerouting the traffic from or drain the traffic from this switch to make it able to the user to update or upgrade or change the hardware. So the topology, so we base our topology in the real BT topology 21 CN network. So we use a Mininet to kind of emulate the network. So it's the switches are split in three different parts. So the tier one, the access node, the metro, and the core. And we have the base station here as the hosts, six of them, and the mobile network operator MNOs. We also use an ONOS controller as an SDN controller. And so the ONOS collects different information from each switches. And basically, the agent doesn't interact, as I said before, each agent or digital asset agent is concerning one specific switches, but it's not interacting directly with it, but going through the honest API. And finally, for the demo, we use iPerf to generate the traffic. Basically, host 1, for example, will be talking to host 7 through the path S1, S7, and S12, H2 to this path, etc. So the scenario will be as follow. The first thing that we'll ask through the Google Assistant to list the hosts. So the system will receive the request and send back a list of hosts. Secondly, we will ask to reroute, so doing some traffic engineering. So we ask to reroute the traffic between, for example, this node and this one. And it's basically, it will happen and we'll get the feedback. And the third, in the third scenario, we'll ask to do some service protection between 2 periods of time. And normally the system will be locked and we have the feedback that is done. And we will ask again to reroute the traffic just to double check that the system is locked. And normally we will have, this request will not be fulfilled because the system will be protected. And finally, we will activate manually the predictive maintenance just for the sake of the presentation to see, and we emulate one of the nodes that that his remaining life will be less than the threshold. And so the agent will detect that and send us an alert through the Slack channel asking for maintenance. And if we say yes, we will see that the traffic will be drained from, for example, this router. And for doing the presentation, as I said, the switch 9 will be the one that the remaining life will be, useful life will be less than the threshold.